Good day to everyone who is watching. In our lesson 3 today in matrices, we are going to talk about the multiplication of a matrix by a scalar. A scalar is like a constant, and then something I never talked about is when a matrix is one, we call it a matrix. When there are many, we call them matrices. So suppose I have my matrix M. Suppose matrix M is equivalent to A, B, C, and what? And D. And K is a scalar. So if I want K times M, first of all I'm going to substitute my matrix M, A, B, C, and D. Then I've said we are going to multiply this scalar in every element that is inside the matrix. That is, the K is going to multiply the A, the K is going to multiply the B, the K is going to multiply the C, the K is going to multiply the D. So my K times M is that one there. And this scalar, we have said they are constants. We can have a 2 times matrix matrix 3, 4, 1, and negative 2, just like that. So if I've been told to compute that, that is the 2 times the 3, 2 times the 1, then 2 times the 4, 2 times the negative 2, to get that one there is a 6, 8, that one there is a 2, and then negative 4. We can have this scalar to be a fraction. Suppose it is a quarter, and I'm having here 48, I'm having a 12, I'm having 8, and then I'm having a 16. So the same thing, the a quarter is going to multiply the 48, the a quarter is going to multiply the 8, the a quarter is going to multiply 12, the a quarter is going to multiply 16. So when you complete this, you shall be having a 12. When you complete this, you shall be having a 2. When you complete that, a 3. When you complete that, you shall be having a 4. So let us go into more. So that is our example 1. Roman 1, solution Roman 1. That is, we need 2A in addition to 4B. First step, substitute your matrix A, 3, negative 1, 2, 4. Then addition of 4 times matrix B, 1, 5, negative 2, 1. So I'm going to multiply the scalar in every element, by every element within the matrix. So the 2 times the 3, the 2 times the 2, the 2 times the negative 1, then the 2 times 4. The same thing I'm going to do here. That is 4 times 1, then 4 times negative 2, then 4 times 5, then 4 times 1. So after multiplying, I'm having a 6, 4, I'm having a negative 2 there, then 8, then addition of 4, that is negative 8, that is 20, that is 4. Now this takes us back to the previous lesson. That was lesson 3 on addition. Sorry, that was lesson 2 about the addition. So we added corresponding elements. So quickly, this is going to be 10, then that one is going to be negative 4, then that is going to be 18, then that one is going to be a 12. So this is my 2a plus 4b. Then Roman 2, this is a half matrix A, then minus a third B. So when I substitute, first of all the matrices, matrix A is 3, 2, negative 1, 4, then minus a third matrix B, which is 1, negative 2, 5, 1. So multiplying, that is going to be 3 all over 2. Multiplying, that is going to be a 1. Multiplying, that is going to be a negative, a half. Multiplying, that is going to be a 2. Minus, that is going to be a third, 5 all over 3. Then negative 2 all over 3. Then a third. Then I add, now these are fractions, 3 all over 2 minus the corresponding element there, which is a third. Then the LCM is 6 times 6, then times 6. So 2 goes into 6 3 times, 3 times 3, that is the 9. Then minus 3 goes into 6 twice, 2 times 1, I get a 2. So in the numerator, when I subtract, that is a 7 all over 6. So my first answer there, 7 all over 6. Then 1 minus minus 2 all over 3. This one here becomes a positive. The denominator there is 1. LCM of 1 and 3 is a 3. So I come back, I multiply 3 there, 3 here. So this is going to be a 3 plus the 3 cancels to remain with a 2 to give me 5 all over 3. So I'm having 5 all over 3 there. Then I go to the next one, a half minus 5 all over 3. The LCM of 2 and 3 is 6. Then times 6 and there times 6. So this is a 3. That is negative 3. 3 times negative 1 is negative 3. This is a 2. 2 times 5 is a 10 to get negative 13 all over 6. Then lastly 2 minus a third. Minus a third. The LCM here is 1. So that the LCM of 1 and 3 is a 3. Then times 3. Then times 3 there. So here I'm having a 6 minus a 1 to give me 5 all over a 3. So this is 5 all over 3 as my a half A minus a third B. Even in matrices, we can have fractions within the matrices. That is when the elements are fractions. Roman 3. First of all, I'm going to substitute my matrix A, which is 3, negative 1, 2, 4. Then minus the 2 times matrix B, which is like that. So I'm going to multiply the scalar. 3 times 3 is a 9. 3 times negative 1, negative 3. 3 times 2, that is a 6. 3 times 4, that's a 12. Then minus my 2 times 1, which is a 2. times 5 is a 10, times negative 2, that is negative 4, then that one is a 2. Then now I can subtract corresponding elements. 9 minus 2, that is 7. 6 minus 4, 6 minus 4, we get a positive 10 because that one becomes a positive. Then 3 minus negative 3 minus 10, that is negative 13. And then 12 minus 2, that gives us a 10. So that is the answer to Roman 3. So Roman 4, that is 2 into my 3a minus the 2. Now in mathematics we have so many ways of killing a rat. One person can first expand, that is opening the brackets. That is to have the 2 times the 3a to be 6a. Then that one to have 4b. Or another person can first find what is inside the bracket there. Then later on you multiply by that scalar there. So using this is 6 into matrix A, then minus 4 matrix B. So when I multiply, this one gives me 18. When I multiply, that's a 12, negative 6. And then when I multiply, that is a 24. Then minus, when I multiply, that is 4, 20, negative 8, and then 4. Now I'm going to subtract. So when I subtract 18 minus 4, I get the 14. 12 minus 8, I get the positive 20. Negative 6 minus 20. Negative 6 minus 20. That gives me negative 26. Then 24 minus 4. That one I get a 20. So try out those numbers and then you'll be giving me a feedback.